Good morning, students. Today we are going to discuss two topics from the chapter Wave Optics, and the chapter number is your 10. Now, the topic last class we discussed the topic of reflection using wave theory, and also we have explained a little bit about wave theory. Now, today we are going to discuss laws of refraction on the basis of wave theory. Now, before starting this explanation, let me to remind you the ray and wave front are perpendicular to each other. Number 1 point. So here you see incident wave front strikes at the interface, and the ray corresponding are perpendicular to the wave front. Now, first ray corresponding to the incident wave front strikes at the point A, and AB itself is your wavefront, incident wavefront. Now at the point of striking, we have drawn a normal, and angle I is the angle made by the incident ray with the normal, and this ray suffer refraction with the angle smaller, and R is the angle made by the refracted ray with the normal. Now you see in another ray, the extreme ray we have considered from the wavefront part. Practically innumerable number of rays are there in the wavefront. So for simplicity, we have considered extreme 2 rays. So at the point A, the ray suffer refraction as it moves from one medium to another medium. You can say from rarer to denser. Now, as the ray suffer refraction, the another ray, which is at the point B of the incident wavefront, has to travel a particular distance for the phenomenon of refraction, and the distance is your BC. Now it is found experimentally that the time the ray takes to move from B to C is same as the time the ray takes to construct the arc from A to D. Now how can we define? What we have to do? We have to calculate the time that the ray takes from to move from B to C. So if we get the time, then for refracted wavefront, what we will do, we will construct a arc, because speed already we know and time already we have calculated. So corresponding to the length v2t, we have constructed arc, and the tangent to the arc is nothing but is your DC, and DC is your refracted wavefront. So here what are the things we have to do? We have to construct a refracted wavefront, and for that we have to know the time factor, and that time factor we have to calculate from here. How much time the ray or the length BC is justified, means how much time the ray takes to move from B to C. That's what we have to calculate, and considering that time, we have to construct an arc with the distance v2t, because two different medium has two different speed of light. One is your v1t, another one is your v2t. So once we construct the arc, then we have to draw a tangent considering the point C. So CD is your refracted wavefront. So incident wavefront and the refracted wavefront we have to find out. Incident wavefront is already there, and for refracted wavefront we have to calculate the time the point B takes to move to C, that is BC. Now once we know the time, we can calculate the length for the construction of the arc. The length is nothing but is your AD, and corresponding to the tangent at point D or on the arc to the point C gives you the refracted wavefront. Now considering the geometry part, sin I, that is 90 degree, B is 90 degree because ray and wavefront are perpendicular. So perpendicular by hypotenuse, that is BC by AC, and sin R again that 190 degree, AD by AC. So sin I by sin R, BC by AC, AD by AC. So AC goes off, BC by AD. So BC is your V1T and AD is your V2T. So TT goes off, so that's your V1 by V2. So you can express this one in terms of refractive index by considering refractive index, absolute refractive index, that is C n equal to C by V. So C by V2, C by V1. So N2 by N1, that is refractive index of second medium with respect to the first medium. That is your Snell's law. So let me to explain this diagram once again. The incident wavefront AB is there, so it makes an angle I. The two extreme rays we have considered, that two rays are perpendicular to the wavefront AB. Now at point A, the rays suffer refraction. So angle of refraction we have constructed by constructing the normal. Now we have to calculate we have to draw the reflected wavefront, and for that we have to calculate the time the point B takes to reach to C. So if we know the time, then considering that time and speed V2 in medium 2, we have to construct an arc considering A as your center. Now we have to draw a tangent over the arc to the point C, and that is nothing but is your refracted wavefront. Once we construct incident wavefront and refracted wavefront, rest part is very simple mathematics or simple geometry, you can say. Now next topic which we are going to discuss is your interference of light. So interference is nothing but the redistribution of light energy. The phenomenon of redistribution of light energy in a medium due to the superposition of light waves from two coherent sources of light is called interference of light. So if you consider a single source, you will get light pattern. If you consider two sources, you will get different light pattern. And the interference is there whenever there is a two source of light at least. So a modification of intensity occur due to the superposition of light waves from two different sources. And here we are considering coherent sources. So this is your new term, coherent sources. Coherent sources are nothing but the sources with constant phase difference or zero phase difference. And coherent sources we can get experimentally from a single source. Suppose you have blocked a source and we have make a pinhole, so light will comes out from that pinhole. Now in front of that block with single pinhole, you place we place another block considering two pinhole. So if you see in front of the block with two pinhole, you will get two different sources, and that S1 and S2 are known as coherent sources. So from a single source you can get two sources, and that sources are coherent sources. Now interference is of two kinds. One is your constructive interference, another one is your destructive interference. In constructive interference, what happens? Maximum light intensity is possible, whereas in destructive interference, light intensity is minimum. So these things we are going to use it in our coming topic, that is your interference of light. There is a huge mathematical expression for this topic, and this one is important for exam point of view, and these two topic is very important, refraction and reflection using wave theory. So please go through this part and try to clear your doubt. So this is all about, more we'll discuss in our coming class. Thank you.